to have, there we go. Sorry, I got a little message pop up. New parking garage requirements and new automatic receptacle requirements. Those are completely new and were not part of any of the previous IECC codes. So let's recap. I'm having a hard time switching my slides here. There we go. Recap of the previous energy codes. So 2015, I think, had a very significant impact to the lighting controls on projects. A reason being is they made daylight harvesting requirements be automatic across the board. So in 2012 and below, you were able to use manual controls to turn your daylight zones on and off. And going into 2015, automatic daylight harvesting was required. And on top of that, you also had to have continuous dimming in spaces such as classrooms, offices, libraries, or other areas where you were doing sort of a task type of work. So what this did is it pushed the requirement to use digital or smart control systems, right? Because in most of these spaces, you would want to have manual dimming on top of automatic daylight harvesting. So you had to have a daylight, photocell talking to a room controller as well as a low voltage dimmer switch talking to a room controller. You couldn't really achieve that with power packs and simple analog devices anymore. Otherwise, those devices would constantly be trying to battle each other for control, and the system just wouldn't work. So this really pushed things into the digital world. 2018 had only a few changes going from 2015 to 2018. And the biggest change there, again, was the open office controls. So in previous energy codes, big, large open office spaces, you were allowed to control those through either schedule-based controls, so your relay panels, or occupancy sensor controls. Going into 2018, schedule-based controls were no longer allowed for open office areas. They absolutely had to be controlled by occupancy sensors. And the other big impact there was that every 600 square feet of an open office space must have its own occupancy sensor control. So you can have any one sensor controlling more than 600 square feet. So you can imagine that, a 2,500 square foot open office, you're going to be at least at 4 individual control zones, which meant, either additional power packs or room controllers. And then on top of that, you still had to account for all the daylight zone requirements in those spaces as well. So they kind of got really complicated there. All right, so let's look at some of the changes that we had in 2021 and start with the occupancy sensor control. So the biggest change here was that all corridors are now required to be controlled by occupancy sensors. So in 2018 and below, you were still allowed to control these large corridors, common areas through schedule-based control. So if you think of a school, right, you can probably grab quite a bit of those areas off of a couple of relays, and it was pretty cost efficient to do it that way. Now you're going to have occupancy sensor controls in those spaces. And when they are unoccupied, you at minimum have to be able to reduce the lighting load by 50%. You could turn it all the way off if it makes sense for that space, but at the very minimum, when those corridors are unoccupied, they have to reduce down to 50% light output. So, and this still does not apply to specialty lighting like display cases and things of that nature. Open plan offices still require that occupancy sensor requirement that you saw in 2018. But the nice thing is they actually went back and allowed an exemption. So if you actually wanted to go back and use time-based controls, you're allowed to do that in the 2021 IECC if it makes sense. So that's kind of the nice thing about this code. In both cases, whether you're using schedule-based controls or occupancy-based controls in those areas, you still have to have daylight controls for open offices. So that means if you did try to use a relay panel, you probably need to make sure it's a dimming relay panel because you do have to have continuous daylight harvesting for those areas. All right, so daylight responsive controls. We did have some significant changes here. So I don't know if you guys are familiar with 2015, right? Most areas that had over 150 watts of artificial light fall into a daylight zone, which was calculated by basically taking the top of the window down to the floor, that distance going into the space, and then 2 feet out to the side of each window. That would give you your rectangle to kind of do the calculation and figure out how much artificial light you have hanging out over that zone. And if it was over 150 watts, you were required to automatically daylight harvest that space. And again, if it was, you know, an open office space, a classroom, library, any of those, they would have to continuously dim. Spaces like corridors, you were still allowed to do switching. So the big change here is now you have two individual daylight zone requirements. So you're going to have a primary daylight zone, and you're going to have a secondary daylight zone. And the calculation changed slightly. So in this case, instead of doing 2 feet out to the side of each window to get the width of that daylight zone, you basically have to go about half the height of the daylight zone. So that measurement from the top of the window down to the floor, take half of that, and that's the distance you're going out to the side. So in most cases, that's going to be greater than 2 feet, in just about every case, really. So daylight zones became wider and they became deeper because now you have two of them. And both daylight zones measure out the same. So you go that length of the window height for the first zone, and then from that go another length that's identical for the second zone. And you basically need to look and see, okay, if you have 150 watts or more in that primary zone, the one that's closest to the window, you're going to have both zones controlled. Or if you have 300 watts in both zones combined. So think of it like, you know, maybe you had 140 watts in the primary zone closest to the window, but maybe that secondary zone had, 160, 170 watts. So that would put you over 300 watts for both zones, in which case you now still have to do daylight harvesting for both areas. And that does mean you probably need to have an individual photocell and an individual relay and dimming channel for each one of those zones. All right, so let's look at, okay, so the other big change here was the fact that you cannot do on-off control for any daylight zones anymore. So every single daylight zone now has to have continuous dimming. So that's going to include your corridors or anywhere else. So again, previously it only applied to classrooms, offices, and libraries and lab spaces. Now you have to have continuous dimming across the board for all daylight zones. So this is kind of a recap of how those primary, secondary daylight zones are calculated. So this image off on the left-hand side here, this is a sectional view of a room, right? So again, the depth of the first and the second zone are calculated by measuring from the very top of the window all the way down to the floor. The size of the window really does not have any impact unless it's so small that the area of that window, the total area of that window is 24 square feet or less. So in that case, you don't have to do daylight harvesting for that area, but that's probably going to be fairly rare. So again, you go in, that height, that distance for the first zone, same thing for the secondary zone, and you're looking for how much artificial lights fall into both of those spaces. And here's kind of a floor plan view of that same calculation. So you're going that distance. The code book currently still shows 2 feet to the side on the actual diagram. However, in the verbiage for how you have to calculate that, it does state half the height or half of this distance you're going off to each side. So that's going to have a pretty big impact because, again, 2 feet here, right, you have two individual daylight zones for these windows. Whereas if you were measuring half the height, you were probably going to go a little bit farther, and then these zones overlap. So imagine a situation where maybe you only had 100, watts of artificial light here, 100 here. You probably didn't have to have daylight harvesting for this window, but because that distance is going to go a little bit farther down the wall, and these zones are going to overlap, you have to calculate them as one big daylight zone. So you're looking at the primary zone being all the way across the space. And then in this case, you probably likely will have over 150 watts between these two zones. So that's how that impacts daylight harvesting. All right, so completely new requirement for parking garages. So none of the previous IECC codes really dove into what was required for parking garages. So it was really kind of hard to enforce. No one really knew what the minimum requirements were for the energy code. They really weren't defined. Some specifiers did add some lighting controls to parking garages. Some added no lighting controls to parking garages. So in 2021, this has been defined pretty well. And what you guys will probably also notice is if you've worked on ASHRAE 90.1 projects, so if you had LEED projects, which do require you to use ASHRAE 90.1 as the code, or if you had government projects, government facilities, federally funded facilities, they also had to have ASHRAE 90.1. And honestly, 2021 requirements almost mirror the ASHRAE 90.1 requirements identically. So you might have actually come across some of these, but in general, so parking garages, you can either control them with occupancy sensor controls or schedule-based controls, so where the lights are completely shut off during unoccupied hours. So if you're using occupancy sensors or schedule-based controls, you have to basically reduce the output of the parking garage fixtures down to at least 30% or completely off or below 30%, but not higher, after the space has been vacated for a period of 20 minutes. The sensors, kind of similar to the open office requirements, the sensors can't control more than 3,600 square feet. So you can't have a group of sensors controlling 4,000 square feet of fixtures. So you have to divide the zones in the parking garage up to no more than 3,600 square feet total. You're also going to have eye adaptation zones for the parking garage entries. And the reason they require this is because you don't want people driving out of a very brightly lit garage into the dark, right? Or vice versa. If they're driving into the garage from a bright sunny day outside, you don't want to have them drive into a very dimly lit space, because if those fixtures are sitting at 30% before they pick up the occupants, it's going to be a hazard. So there's a couple of different ways of achieving those controls. A lot of specifiers I've seen try to use photocells to let those daylight transitions know when it's dark or light outside. Unfortunately, that's really hard to achieve with most systems. So even if you're using occupancy-based controls for the entirety of the garage, I think the best approach for those daylight transition zones is still going to be some sort of a time-based system, a panel-based system that you can basically schedule astronomical times into that device to let it know when the fixtures need to be bright and when they need to dim down, because it actually works the opposite way, right? During the day, those daylight transition zones should probably be at 100% output. And at night, you want them to dim down to at least 50%. That way they're not as bright. So it kind of works the opposite of a photocell, and very few systems out there have the logic to allow the photocell to work backwards, because typically photocells want the lights on full bright during the night and off during the day. So you're kind of trying to reverse that logic. And again, not a lot of systems allow you to do that. Apologize. You're also going to have daylight controls within 20 feet of your walls in the parking garage if those windows or open part, I guess they're not really windows, they're completely open, but if those openings are 40% or greater of the total wall area, and we'll kind of look and kind of show you how that's supposed to be calculated, but in most cases, that's going to be the case. So most garages have pretty wide openings on the side. So if those openings exceed 40% of the total wall area in that space, you'll have to daylight harvest that zone of 20 feet away from that wall, and at least be able to reduce the lighting loads by 50% if there's adequate daylight for those areas. In most cases, they do require schedule or sensor-based controls, but I think in most cases, things are going to go the occupancy sensor way, because again, most garages can be accessed 24/7, and most people don't want to have to go into a completely dark garage, because the schedule, if that reduces at a certain time, you have fixtures sitting at no more than 30% output, and that might not be bright enough for people to feel safe walking into that space. So I think most cases, you're going to see occupancy-based controls be the requirement. And I think currently the easiest way to achieve that is going to be in-fixture sensors. Technically, if you have each fixture working completely standalone with its own sensor, you're still meeting all of the requirements. Most occupancy sensors have daylight harvesting built into them. Wattstopper has this option as well. So you can basically activate the daylight harvesting for the fixtures that are within that 20-foot zone near the windows in the garage, or the openings in the garage, and then just do occupancy sensor only. So the only drawback there is you would, end up with that popcorn effect where each fixture picks you up individually and comes on its own as you go through the space. You're not going to be able to do zoning unless you go with a smart system or some sort of a wireless system to where these devices can communicate between one another. So when it comes to daylight harvesting, so this is kind of how you figure out whether you are over 40% or not. So these are kind of your openings alongside of a garage wall. So this is the area that you're looking at. So the wall is being calculated basically from the floor on up to both sides and to the lowest structural member in that garage. So if you have these girders, right, that you typically see in a garage, you're not measuring above those girders. So that's your total wall area. And if these zones here, the fenestration areas, if they exceed 40% total of that wall, then you will have to do automatic daylight harvesting in those spaces. All right, so another big one, and this is probably the one that frustrates people the most because there's definitely ways to cheat this, and people complain, and that you have to install all these additional devices and either power packs or receptacle controls, and then people just end up plugging in plug strips. So I always get this question of why do they even have this requirement? And honestly, I don't have a good answer, but it does make it a little bit harder for people to cheat this. If your receptacles are controlled, or at least half of them are controlled. So this way they are kind of limited to what they can plug into what. And typically what they want you to do is for control receptacles, you're trying to plug in your devices, your printers, your computers, and things of that nature that you don't necessarily need to have running 24/7. So if you left that space, you're no longer using the office, your computer is not sitting there running 24/7. So basically the new requirement is that any office space, you've got your conference rooms, copy print rooms, any of these spaces that would have these kind of devices, computers built into them, or some sort of workstations built into them. They want you to have the ability to control 50% of the receptacles. And those controls can be done either through schedule-based controls, occupancy-based controls, or separate system controls such as security systems and things of that nature that would allow you to basically turn those receptacles, the power to those circuits off during unoccupied times in the building. So which method is used is really going to depend on the project. It's a project basis because in some cases, occupancy sensors will make sense. In some other cases, schedule-based controls will make sense. So for example, if you know that an office space is going to be only occupied during certain hours, you might be able to do schedule-based controls because, again, you can control multiple rooms, multiple private offices off of a single relay. You'd be sweeping the power to the circuits across multiple rooms, whereas if you were using occupancy-based controls, you would at least have to have a power pack in each one of those individual spaces that would tie into that occupancy sensor. Schedule-based controls won't make sense in all cases because you will have facilities and office spaces that are going to be occupied outside of normal, business hours. So, hospital facilities, they're going to have their offices, and there's going to be different shifts. Those facilities are open all the time. So in that case, you're probably going to be looking at occupancy sensor based controls. So the only areas that are going to be exempt from having to have those controls are going to be receptacles that require the loads that they're controlling to be operating 24/7, 365 days a year. So if for whatever reason that device didn't need to run even one day out of the whole year, you'd still be able to, or you'd still need to have the ability to control that receptacle. Another challenge is going to be that, open offices, you have your modular furniture out there, the cube farms that oftentimes have built-in receptacles in those. And 25% of those would also have to be automatically swept off. So the challenge here is a lot of times contract plans don't always call this stuff out, right? They don't have that level of details included usually in a lot of the construction documents. So it's going to be a challenge to kind of budget that, but it is a requirement nonetheless. And there are two different options. So when they say you have to control 50% of the receptacles in the space, that means you're either controlling half of the entire receptacles in the space. So if you have two receptacles in an area, one of them is completely controlled, or you're controlling half of both of the receptacles. If you are controlling the entire receptacle, then an uncontrolled receptacle has to be located within 12 inches of the controlled receptacle. So I think in most cases you'll see that spaces will require basically all the receptacles, one half of it to be controlled. So you'll see a lot of these split yoke receptacles going into these kind of spaces. So again, the ability to use time of day scheduling is the requirement if you're using time-based controls. So where that makes sense. Each day of the week, you have to be able to schedule independently. So you can't really use a super dumb system like a torque time clock or something like that. Something you're going to have to be able to adjust those schedules and be fairly flexible with those schedules. If you're controlling it with a time-based system, you can't control more than 5,000 square feet of receptacles together. So very similar to what you have for time-based controls for lighting in open office areas as well, because if you are using a relay panel to control your open office lighting, you can't control more than 5,000 square feet together on a single relay. So you have to kind of divide that up into multiple zones. And you also have to provide, in both cases, you have to provide the occupant with an override switch. So for your lighting as well as for your receptacle controls, with an override of no more than 2 hours. If you go the occupancy sensor route, you're basically limited to the same thing as you would be with your lighting load as well. So the same occupancy sensor that's controlling your lighting loads will also have to control your receptacle loads, and you have a 20-minute limit. So you cannot go above that for the timeout period for the plug load receptacles as well. Separate system controls, again, security systems, I don't think we're going to see a lot of this, but if you had some sort of a key fob system that allowed the building to know when a space is or is not occupied by someone, you can use that system to provide some sort of a contact input, or use its own relay-based systems to basically turn off the receptacle loads after 20 minutes of vacancy of that space. So this kind of goes over what you might see on specifiers plans. So again, workrooms and offices, a lot of times they'll basically shade the control or the controlled receptacles in the space. So in this case over here, they're basically shading these two guys up here. This one's unshaded. This isn't really quite meeting the 2021 code because again, the shaded receptacle would need to be within 12 inches of an uncontrolled receptacle. So in this case, they're not really meeting the requirement. This probably meets the ASHRAE requirement, which this is based off of, but not the 2021 requirement. So in this case, I think it would make more sense to do a split yoke receptacle in all of these cases and control just maybe the top half of that receptacle. And on top of that, those receptacles would also have to be labeled. So any controlled receptacle has to be clearly labeled, stating that it is controlled. So here's just another example of what that would look like. So different specifiers are going to use different symbols. So definitely keep an eye out for that. If you know that your project needs to meet 2021, make sure that the specifier has this stuff called out and you guys are capturing it in those locations. So to kind of wrap things up, I kind of want to go over some of the offerings that WatchTower has as solutions for plug load controls. They're one of the manufacturers that has quite a few different options depending on what kind of system you're using. So anywhere down from your analog power packs all the way up to your digital room controllers and even some wireless applications. So in this example here on the left, so this is a pretty basic analog setup where you have a single zone of dimming for maybe an office space. You've got your occupancy sensor, your power pack for your lighting load, and a low voltage override switch that also serves as a dimming switch. So this is their DCLV2 switch. They're pretty handy, pretty cost efficient for spaces that have a single switch location, dimming requirements and the requirement to do vacancy sensor controls. And then basically you're slaving that second power pack off of the same sensor. So the same sensor controls both power packs, lighting, and the receptacle controls. And then you're basically grabbing, again, that circuit that's going to be controlling half of that receptacle and controlling it with this power pack. If you had to have a space that maybe had multiple dimmer locations, so you had to have three-way dimming, something more complicated, you can achieve that with their digital systems, room controllers, digital sensors. Plug low control, just basically another room controller that's on off only, and you plug that in just like you would any lighting room controller, additional room controller, right into that same device. And basically the sensors are programmed to control both loads together. You're running that receptacle circuit through this room controller and down to your controlled receptacles. Another couple options they have are wireless. So the analog devices offer a wireless setup as well as the digital systems. So again, same setup. You have the same exact switch that we had in the previous example, this DCLV2 low voltage dimming switch, power pack, same sensor. And what you have here is a device, it's a wireless transmitter device that basically is activated by the occupancy sensors to let it know when to send that signal off to the wireless receptacles. So the wireless receptacles replace your normal receptacle. And then if you have additional receptacles that need to be controlled on that same circuit, you can slave it right off of this one single wireless receptacle. So you just basically need one per every circuit of control that you have in the space. And then any additional receptacles are just going to be your standard receptacles. Again, split yoke probably to just be able to control half of that receptacle in space. And you have the exact same setup going on over here with your room controller. Same concept, except you have Cat5 cables between your devices. Again, this is where you might have something like multi-location dimming or additional requirements. Potentially you have networking requirements for the project, and you have to have digital devices instead. But these devices here work pretty much identical to what you have in this space over here. So, and that just about wraps up what we have for the new energy code requirements. So we'll open it up to questions and comments.
While Greg is opening things up for everyone, just want to kind of point out to you that we have a whole team dedicated to your controls needs. So generally speaking, keeping up with all of these changes is pretty laborious. It's difficult, and Mike and his team have done a good job of doing that. And so we fully understand that trying to keep track of this on your own is pretty difficult. So there are a few resources that we're going to follow up with after this presentation. One of those resources, or it's a link to more or less a Cliff's Notes version of the 2015 IECC from WattStopper, as well as I believe, Mike, we have 2018s available as well. 2021 is not available just yet. WattStopper is still formulating that, but it's really nice when you're looking at a new set of drawings and recognizing the fact that you're in an area that you're going to have to meet a certain code requirement and being able to reference back. So I would highly urge you to take a look at those details when they come through. So I do see that we have a question about enforcement. So this is a really good question, and this is why this is so difficult to have this conversation, especially as contractors. So keep in mind that we have designing professionals that have a requirement as a part of their license, and also as a part of it's basically a liability concern. They have to hit certain code requirements regardless of if it's being enforced or not. And as a contractor, it makes it very difficult because you're seeing a drawing that may or may not include some of the devices that you would expect to be there depending on the jurisdiction you're in. And so it puts you in a really difficult spot. And so ultimately what I would say is, at least as a contractor, the way that I would recommend you approach that situation is to ask for a code compliant bill of material, and then provide that as a cost add if it's not reflected in your drawings. So it's not uncommon for Mike and his team to provide a set of items and services to meet what's shown on the drawings, and then provide a cost add for you, so that way you can provide it as an adder, so that way you are covered both ways. And so that's what I would recommend there. And then to answer your question about actual enforcement, there's not really a whole lot more that we can offer or that we've seen, other than the fact that we know that it's even more granular than a jurisdiction by jurisdiction. We've seen it where it's individual by individual in those jurisdictions as they interpret those codes and how they should be rolled out. So that's a really difficult question to answer, but that's about the best that I can offer. Is let's make sure that we quote what's on the plans, or let's bid what's on the plans, and then let's also provide the cost add, so that way it's not something that you're expected to cover on your end. So that's what I would say to that end. And Mike, do you have anything else that you would add to that?
No, I mean, yeah, the code clearly states that there has to be a commissioning agent that goes through and does functional testing. We have, in the past, seen a lot of confusion as to who's responsible for that. I think it really kind of falls on the general contractor to hire a commissioning agent for their project if they know that it is required per code. A lot of times we've been asked and approached to see if we can do the functional testing, and again, it has to be someone that was really not involved in the design process of the project that is actually going through and doing the testing. So otherwise, it's a conflict of interest. You can have a specifier have the same specifier go through and actually do the functional testing, so long as the individual in their office was not involved in the actual design process of that project. So we've seen that be an option as well. But there are specific commissioning agencies out there that will go through and do that testing for the project.
Yeah, thanks for touching on that, Mike. So we got another question that came in asking if we knew when the state is going to adopt the 2021 code. So yes, we do know when that's going to take place. That will happen January 1, 2022. And what that means for all of us is if there was a set of drawings sent in for code review on December 31st of this year, it will fall under the previous energy code, more or less, okay? As of January 1 and after, anything submitted for review will be under the new 2021 code. So that's kind of the dividing line. And then keep in mind, that's at the state level. So, if I have a specifier in Colorado Springs that submits something now, it still will be under 2015 energy code, because that's the minimum code requirement that the state will allow moving forward. However, if you're in Grand Junction and you're a specifier in Grand Junction, or you're a contractor doing a design build in Grand Junction, and right now we're budgeting to 2009 energy code requirements, I would start to let everyone know that unless we get submitted for code review before the end of the year, we need to look at the cost implications if it's submitted for code review after the first of the year, because they will then have to comply at minimum with 2015 if they don't adopt something even more recent. So that's a good question to ask. The other thing I want to point out as well, keep in mind that all federal dollars and state dollars are going to have to meet 2021 code compliance if it's submitted for code review after the first of the year. So there's a lot of moving on from our perspective. When we're alongside contractors, it's a lot more sticky than people think at first blush. So a lot of it has to do is where's the money coming from, right? As to what code you're having to adhere to. So hopefully that answers that question. Ted just sent out one. Is the state 2022 requirements for all cities, counties, etc.? So yes. So that's why we're having this meeting now, 6 months out before the end of the year, is to let all of our contractors know that do design build work that yes, places that we were doing any kind of construction before under 2009 codes or more lenient codes, that will go away if we have not submitted for code review before the end of the year. So that's going to be statewide. And so we want to make sure that everybody understands that, and the state will enforce it. Now, what that code will entail, that's up to the jurisdiction, if they're going to adopt 15, 18, or 21. So depending on what's going on there, you'll see variation in each jurisdiction. So I would tell you right now, if you're in Southern Colorado and you're working in Colorado Springs, for example, it's going to stay 2015. We haven't heard anything other than that so far, but as you know, things tend to change daily. So stay tuned. But what I would say is if you've got a design build job, now's the time to either get it submitted for review or start to get things dialed in for the cost implications that are forthcoming. So, which obviously the submittal for review is the most advantageous. Does anybody else have any other questions that you'd like to lob Mike's way or my way? As we wait for just a second, I want to let you know that our service group is awesome. If you've not seen our controls drawings, you need to see them. They are extremely detailed and they actually show you how to build the job. And so if you've not seen those and you have someone that you know on the MH team, feel free to reach out to them and we'll send you a generic set so you can kind of see what you can expect. And the other thing too is we're not going to leave you hanging out in the field. A lot of times Mike, his team, they're carrying labor dollars to come out and assist in the pre-construction side of things. So that way, as you're laying out your plan for construction, we've got a pre-construction meeting usually included. And then also for startup and owner training, because those are pretty heavy labor details, and it's difficult on the guys in the site to finish those procedures. So we include those. If it's not included in the base price, a lot of times we're going to include it as a cost add, but one way or the other, we're going to include that. So I just want to make sure that you're aware of those things. And then I've got a question that just came in. Am I seeing these enforcements outside of the state of Colorado? And the answer is yes, we are. And again, it follows federal guidelines. So as the Fed requires certain minimums, you see that more or less pushed at the state level, and then states are adopting those. So for a group like us in Colorado Springs, where we have various government installations, we've been seeing the more stringent energy codes even before our local AHJ required those kinds of controls. So yeah, so we're seeing it in and outside the state. So you'll see it up in Montana, Idaho, Wyoming. You'll see it in all of those municipalities and entities there. And so, Mike, do you have anything else you want to add?
No, yeah, I guess touch base on your points for the code adoption enforcement. So, yeah, again, it's going to get adopted by the state overall. And what that means is, again, any state dollar projects, your schools or anything like that, those will have to meet the 2021 requirements because they're adopted at state level. Even if they're inside of a county or jurisdiction that might still be under 2015 IDCC. So any other projects, commercially private funded projects, those can still go and be under 2015 if that's what that jurisdiction has adopted. But if it is a state funded project, government funded project, tax dollars, those will have to meet the 2021 requirement.
Thanks for clearing that up. All right, everyone. Well, thank you for taking the time to meet with us. Again, we very much appreciate your efforts to join us. Mike's spot on. This will put you in a very good place as we navigate the path ahead. So again, thank you for your time, and we look forward to talking with you soon. Take care.
Thanks, guys.